this video, we'll be creating collectibles like coins or items that our player will be able to collect and use for upgrades or unlockables. We'll be creating this in a reusable way so that we can add an infinite amount of collectibles and items that can actually run their own code and do their own things. In a future video, we'll be linking this into the UI and giving our character the ability to actually use the coins that we're creating. So make sure to subscribe and hit that bell notification so you don't miss that. And if you have any other mechanics or ideas that you'd like to see built, make sure to leave a comment. Now let's move into our editor. To get this started, we need to go and set up some collision layers. Now I'm going to show you one of the simplest and easiest ways of getting this sorted. It's always a good idea to learn the very quick way of doing something, so when you're prototyping you can just have something done and ready. And then we'll go into what my actual preferred method is of doing this for larger projects. So the first thing we need to do is go into our project settings, and then under general we're just going to type into the filter section layer. And then you'll see where it says layer names. We want to click 2D physics. Now our first layer is going to be called level. This is going to be the level that our character is in. The next one will be called player. This is going to be the layer that the player is on. And then finally we want a collectible layer. This is going to be where any collectibles that can be interacted with or collected will be on. Now layers are semi-complex in Godot, but they're extremely useful and they can be quite easy to understand. But first, let's actually create our collectible. We're going to go of other node, so new scene, other node, and this is going to be of type area 2D. Now an area 2D is literally just a collision area. It has signals for when something enters and exits its little area. But for that, we're going to need a collision shape. This is going to act as its area. We're going to give it a new circle shape for now, and this will do size and shape wise until we give it a sprite. So let's go and give it a sprite. Let's go and actually give the sprite a texture. I'm going to be using the Kenny asset pack as per usual. Then I'm going to go down into tiles, and near the end here there should be a coin tile. There we go. So this will be our little coin. I'm going to change the offset to -6. Yes, -6. That basically puts the bottom of the coin on the floor, which is fine for what we need it. We're going to move the collision shape up a little. And then we're going to hit Control S to save this. Now, I'm going to save this in a new folder, and it's going to be in the collectible folder. And then we're going to create... now that'll do. Don't forget to rename it. I sometimes forget to do this. We're going to call this the collectible. Make sure I'm spelling collectible right. _entity. Because it's an entity that can be collected. I'm going to save that. Finally, we want to add an animation player to this because, you know, some games have coins that have little animations like they bounce and float and move around, which is really nice. And we're going to want that. So let's go and give a script to our collectible entity of type collectible entity. Let's give it a class name. Collectible entity. Like that. I'm going to give this the class name base collectible entity. Now I usually like to use base for things that other things will inherit from. In this case there won't be much inheriting going on, at least from this specific script, but it's always a good habit to be in just to make sure that, you know, in the future if you want something you have a place to inherit from. So the simple method is going to be, first we want a ready function. We're going to type pass. And then we need to actually set up a function for what's going to be called, for accepting a signal, and that's going to be the onBody entered signal. So if we go into the ready function and we type in connect, you'll see that a bunch of different strings pop up: area entered, exited, shape entered, exited, body entered, exited. Now, if you go and actually click on your area 2D and you go into node, you can see all the signals that it requires or all the signals that it can use. Now, I'll get into the reason why I don't enjoy this method too much. So we'll use body entered because we're going to be looking for a player body, which will be our character body, or, you know, our player's character body. There we go. This is going to be for on_body_entered. Now we're going to create a new function called underscore on body entered. So what does body entered take? Let's actually go over to our signals here and we can check that on body entered it takes a body of node 2D. Now we can check specifically for node 2D, or we can check for character body 2D. Because the character that we're going to want to check is going to be of type character body 2D, we're going to want to make sure that we're typing this as a character body 2D, which inherits from node 2D. It's going to be of void return type. Now, this is the simple method. The simple method is first doing an if check. So if we want to check if the body is not, so if not, body dot is underscore in group, and then we want to check for a group, which in this case will be the player group. And if it's not, we want to print pass, and then return out the statement. And if it is, we are going to print collect. So let's go to our player. Going to actually click on the player, go into the node, into groups, and then make sure that we have the player group. We do. So we have the group set up and it's doing all of the things. We now need to go into our collectible entity. If you left click on that and you come down to here where it says collision, we need to check the layers and masks. So this will be on the collectible layer and it will be looking for the player layer, or the player on the player mask. Now, the layer is what the thing is currently on, and the mask is what it's checking for. So in this case, it's on layer 3 and it's checking for layer 2, specifically the player layer. So let's go into our player. Let's go and check its collisions. We don't want it on the level layer, but we want it checking for the level layer because it needs to collide with the floor. We're going to want it on the player layer and looking for collectibles on the collectible mask. Now if I hit Control S and save, Control S on save on the collectible entity, I'm going to create a new container in the main scene. It's going to be of type node2D. I'm going to call this the collectible underscore container. Put this above the entity container, so it renders behind the player. And now I'm going to use Control and Shift to add our collectible entity. Now let's move this over to where the player is. Then hit F2, not F2, F5 to play the game. So we're printing now. So let's look at the debug, or look at the output on the debugger and walk over the coin. And you'll see that it says collect. Every time we walk through this area, it's collecting or printing the collect thing, which is perfect. That's the simple, easy way of making these things interact and actually do something. Now, if we go back to this script, we can change the print to do whatever we really want it to do. Now, this functions. I personally don't like checking individual groups like this. I feel like sometimes that can be underwhelming for customization. Like, I want to be able to customize each individual step of certain things. So let's actually move on to the preferred method, or my preferred method. So for this, we need to remove the code that we currently have. We'll write pass in ready to remove any errors. We're going to create a bunch of new lines. We're going to pull in our sprite and create an onReady variable, and our animation player and create an onReady variable. I'm doing this by holding left click, control dragging, and then control dropping, and it creates automatic onReady variables for you. I'm going to typecast these as a sprite 2D and as a animation player. Is that spelled correctly? I don't know. Oh, now it is. Now we're going to give it a signal. The signal is going to be for collect underscore entity. Now, as I said before, areas already have signals built into them, but this is going to be a specific signal for this specific area, and this specific area being a collectible, it needs that signal, right? So in the ready function, we're going to connect this collect entity signal, and we're going to connect this to on underscore collect. Now we're going to create a new function for onCollect. Void type, or void return type and no parameters. And then in onCollect, we're going to just write a print statement for printing collected. And then we're going to Q3 this current scene. Now Q3 just deletes the scene, it removes it. So that will delete the coin for us, so we won't have to handle that anymore, it'll just be gone, which is useful. Now we need a way of actually firing this signal and running this code. So I'm going to hit Control-C to copy the collect entity signal, just so I remember and keep it in my mind, and in the clipboard. And we are going to move on to creating a connection handler. A connection handler is, for like very simple terms, it's going to be added onto the player as another node, and it's going to handle all of the individual connections that need to be handled for, say, picking up a coin or interacting with a door, talking to another NPC, pretty much anything that requires that type of connection. So to do that, we are going to create a new scene of other type. Now this is also going to be an area 2D. This is going to need a collision shape. Let's go and set that collision shape up real quick. It won't need a sprite or anything else, just a collision shape. We're going to hit Control-S to save this. We're going to rename the area 2D to connection underscore manager handler. Hit Control-S to save. Save this in the handlers folder. Now we're going to give it a script. Give it a class name. Collection handler. Now, in our ready function, we want to connect, so func underscore ready. We're going to want to connect its on area entered signal. The on area entered signal, okay, signals, takes an area 2D or an area, it just takes an area 2D. That's what we want to kind of look for. So connect area entered. We'll connect this to on underscore area underscore entered. Create a function for that. Give it its required parameter of area of type area 2D. Give it over a void return type, and then pass. So we are going to very quickly want to make sure we've selected this, go down to its collision, deselect its layers, and this doesn't need to actually be on any layer, but it does need to be looking for the collectibles on the mask. So we now need to sit here and think about what we need to check for. So we're going to write if area is equal to null, return. So don't run any code if the area doesn't exist, which is a really simple null check. It may not even really be necessary, I just like to do them. Now we need to check what the area actually is. So we'll go if area is base collectible entity. So that's the custom class we created for our collectible entity up here. So if it is this, we want to go area dot emit signal collect underscore entity. Now, the reason why I'm doing this, you can do this in a lot of different ways. The reason why I'm doing it this way is because now anything that enters this area, if it is of type base collectible entity, it will emit this signal. And if it's not, it won't do anything, which is really useful because in the future, when we go to expand this and say we want to interact with a lever, and it will be of type lever entity or switch entity, we can then start adding in extra pieces of code to do those individual things and allowing that connection to be made. So with this done, let's go back to our collectible entity, hit F5, actually see this run and go and see what's happening. Right now, nothing. And that is because I forgot to actually add the, not the collectible entity, the collection handler connection handler to the player. Make sure that that's added. I'm going to move this up so it's actually covering the character's body. I'm going to hit F5, try again, and there you go. We've Q3'd the coin, so the coin got deleted, and in the output down here, it's actually printed out our collect statement. So now that we've actually got things connected up, let's actually get it kind of storing specific variables and kind of connecting to other things so we can actually start using this in a fun way. To do this, on our collectible entity, I'm going to add a new onReady variable, or exported variable, sorry. So we'll do that here. It'll be at export var, and this will be called the collectible underscore resource. And right now we'll set this, or we'll typeset this to equal a resource, and that's going to be of null. Now, let's actually go and set up a customizable resource that is designed for what we need it to do. Now, to do this, I'm going to go down into the scenes. I'm going to create a new folder. This is going to be for resources. And then under resources, I'm going to add another new folder called collectible. And now inside of collectible, I'm going to add a new script. Now this script, we're going to just call base collectible resource. Going to put some underscores between those words, and it's going to inherit from the resource type. So when I click create, and we go and open up this, you'll see it's extending resource now, which will allow us to create resources off of this script. Perfect. But this collectible resource, base collectible resource, will be designed so it can be modified and used for any type of resource, not just coins, right? So to do that, we need to actually think about the types of things that this will require, or every item that we create will require. So the first thing I can think of is a variable. We're going to create an export so we can modify them in the editor. A variable for collectible underscore sprite. Actually, we'll call this collectible underscore texture. This will be of type texture. And we'll set it equal to null. So it needs a texture so we can actually change the sprite. Then we're going to need a type, right? We're going to need like a naming convention for these things to allow us to kind of differentiate between the resources a bit easier. So we're going to create a new export. It's going to be for var collectible underscore type. We're going to set this as a string type and give it an empty string as a starting value. Now hit Control S and save. Now this is the really basic resource setup. We can create a resource from this and we can add a texture and a type. But before we do that, I want to go and create a new script again. So one more new script. This is going to inherit from base collectible. This helps if I remember to add a class name to the resource. Underscore name. So go back and add a class name to our base collectible resource for base collectible resource. Yes. Hit save, make sure that it's saved, and now once again go and create a new script, inherit. We can just leave it as no for some auto completion in a second. So we'll call this one currency resource. Because this specific script will be designed for handling all of our currencies. Now, the reason why I said leave the inherits is because if we go to where it says extend here, we can now use autocorrect to correct our extends into base collectible resources. Now it's inheriting from base collectible resource. So what is this specific script going to need? Well, a currency requires a value, right? So let's go and export a variable for value. This will be of type int, and we'll set this equal to 0. Let's Control S and save, and make sure I type that correctly. There we go. So with this done, let's actually go and make our resources. I'm going to create a new folder in the collectibles folder, and I'm going to call it collectible space resources. Now in here, we're going to create a new resource. Before we do this, we want to add a class name to this as well. Class underscore name currency resource. Now we can go and add a new resource of type currency resource. We're going to save this as coin. So if you plan on having different coins, you can name this a bit differently. So what I'm going to do is, because I can eventually plan for adding coins with higher values, I'm going to name this coin 1. This is going to be of the for the value of the coin that has 1. So now you'll see up in the top right here in our inspector, if we actually go in and click on our new resource, we've got these values. We've got the value, we've got the collectible texture, and the collectible type. So the type is going to be of type coin, and the texture, I'm going to go into our assets, go down to our tiles, scroll down for the coin. Now that's our coin and our texture. Let's go back into our base collectible entity, this one. Let's change the collectible resource to base collectible resource. Hit Control S. And then under collectible entity, you can see in our inspector here, we now have a collectible resource. So we can use quick load and load up our coin resource. Then we can click on that and get our resource values, right? So with that done, let's actually go about setting up our sprite. Now I'm going to show this off by first removing the texture from our character or from our collectible entity. I'm going to go into the collectible entity script. Then under our connection, what I'm going to do is I'm going to write sprite2d dot texture equals collectible resource dot collectible texture. Hit Control S. Now let's hit F5 and see what happens. You'll see our sprite becomes repopulated with the texture that we wanted to repopulate it with. Now with that done, we need to figure out a way of actually sending this value somewhere, right? It's now stored in our entity. It's got its own resource. We now need to send it somewhere. So in previous videos, I showed you how to set up a signal bus. If you haven't watched those or don't know how to do that, it's very simple. All you do is create a new script in a auto loads folder, so it's easy to find, like in here, in this case. Call it signal bus. Go to your project settings, auto loads. You click this little folder icon. You find the script that you want to add, and then you just click the add button, and it will be placed into your auto loads. So I'm going to go to my signal bus. I'm going to create a new signal. And this signal will be for collect underscore entity. And this is going to take a entity underscore resource. If we want to make this even easier to read, we can call it collectible underscore entity resource. And this will be of type base collectible resource. Now I'm going to make my life a little bit easier and copy these parameters. Then we create a new function, so func emit collect underscore entity, paste in those parameters, give it a void return type, and now we just have to emit the signal. So we write collect entity dot emit, and then in the parameters for this we just pass in our collectible entity resource. So that's our signal set up. We now need to actually fire the signal. Let's go back down into our base collectible entity, or our, base collectible entity. Now on collect, we, instead of typing print, what we're going to do is just type signal bus dot emit collect entity, and then we're going to pass in the collectible resource that we have added to our scene. Then, with this firing that signal, we need to go into the... We actually need to make a new scene. So let's go and create a new scene, because we're going to need something that now listens to this signal. And this is where the kind of big thing is going to come in of creating a manager. Now, a manager is kind of what its name entails. A handler will handle specific functionality within specific scenes, right? A manager will manage a lot of different information for chunks of the game. In this case, the collectible manager will handle the collectible things. So anything that fires that collection signal will be managed by the collectible manager. In this case, it will be either adding to a counter, firing off another signal to set up more UI related things. It's just that kind of hub for these types of signals, or to connect to these types of signals. So for that, we're going to create a new scene of type node. We're going to rename this to collectible manager. Going to hit save. We're going to create this into a new folder. I'll call it managers. Save that. Now we're going to give it a script. Give it a class underscore name of collectible manager. Go and create our ready function and then hit pass. Because before I forget to do anything, we're going to go back to the main. I'm going to add a new node. This one is going to be the manager underscore container above the camera. And then I'm going to use Control Shift A to add the collectible manager. Now that that's added into the scene, I won't forget. Sorted. So let's first go and connect to that signal that we're firing. So we type in signal bus dot connect, and we are going to connect this to the collect underscore entity signal. And then we're going to use a function that we have to create called on entity underscore collected. Create a new function for that. Remember what it takes. It takes a collectible underscore resource of type base collectible resource, void return type. And now in here, we're going to write pass. So here's a bit of a fun thing. The base collectible resource doesn't actually have a value attached to it, right? That's the currency resource that has a value attached to it. But because of the type of resource that we're passing through, we can still access the value resource. We can still check for what that actually is. And to do that, we're going to be using a match statement. Now, the reason we're using a match statement for this is because we want to be able to add as many types of entities or collectible entities as possible, right? So in this instance, we're going to add a coin. Now to do that, we're going to write match entity underscore, collection, sorry, there you go, collection resource dot collectible type. Now we're going to put some colons after that. So for those of you unaware, match statements are quite similar to if statements, but they are extremely type strict, meaning they match to extremely specific things, and they are faster. So in this case, we want to check for a string, because the collectible type is a string, and the string we want to type or check for is coin. Now, before you do that, a really good thing to do is to just check for an empty string. So if the string is empty, we put a colon, then we hit enter again to create a new code block within that. All we're going to type is return, because if there is no collectible type and we've forgotten to do that, we don't want it to do anything. Now, for debug purposes, you can actually type a print statement just for error no type found. So whenever we go across this, or actually fire that signal and there's no specific type selected, let's go and test this into our collectible entity. Let's go and change the collectible type to an empty string. Hit F5 and see what happens. We're getting that error, no type found. The collectible disappeared, but we're still getting that error. That's like, hey, we forgot to add a type to this. So let's add our type to this of type coin. Now let's go back into our collectible manager and add a new case or a new statement to match against, right? We've checked for an empty string. Let's actually check for our coin. So if the entity type or the collectible type is of type coin, what do we want to do? Well, we don't have a UI or anything else that can actually take in this information yet. So where I plan on doing that in a future video, for now, we're just going to create a new variable, and it's going to be of current underscore coin underscore count. And it's going to be an integer type, and we're going to set that equal to 0. Now, in our statement, we're going to just write current coin plus equals collectible resource dot value. Now you'll see that I'm not getting any IntelliSense or autocorrect here, and that's because it doesn't know that value exists within this scene, right, or within this resource, but we know it does. So let's now write a new print statement. We're going to print out two things. The first thing is coin value. Then we are going to add we need to write plus collectible resource dot value. Then we'll write another plus, use a break line or a new line in this case, which is backslash n. And then immediately after that, we are going to now write what our current coin amount is. So plus current coin count. We can add current coins. There we go. Now, let's actually go and give this a test and see how this is functioning. Pay attention to the debugger down here. So we check the output and we crashed. Now, why did we crash? That is because I completely forgot to use str. So str is a string conversion. It converts whatever you want it to into a string. In this case, we want to convert the collectible resource value into a string and the current coin value also into a string. There we go. Is that one too many? No, that's correct. There we go. Let's try that again. There we go. Now we've got our coin value and our current coins. So let's go and add a bunch more coins and go and check and make sure that this is functioning the way we want it to. So under our collectible container, I'm just going to move this one here, Control D to duplicate, Control D to duplicate, Control D to duplicate, and we'll do one more. Now we'll hit F5, play the scene again, and see what happens. The coin value always is 1, perfect, and our current coin value is incrementing upwards, which is what we wanted to do. Now, the final thing that we actually want to be handling in this is animations. How do you do this type of functionality with animations? Well, if we go back into our collectible entity, you'll remember we added an animation player. Let's go into the script. Let's create a new function. Func handle underscore animations of void return type. And we're once again going to use a match statement. We're going to match the collectible resources dot type. And if it's of null or no type, or the string is empty, we're going to return out. However, if it does have the type of coin, we want our animation player to play our animation. Now, what if you want to add multiple coins, right? Your animations might kind of have issues. So there's a few ways of checking this. I'm personally going to just check for the value of the coins. I like storing my values as a kind of set thing. So in this case, I will have a coin value of 1, a coin with a value of 10, 15, 20, 50, and 100, right? So all I have to do is go if collectible resource dot value is equal to 1, play the animation. But what animation are we playing? I haven't created an animation yet, so let's give this, really quickly give this a sprite. Give it the sprite coin. Control S. Now let's go to our animation player. Let's create a new animation. I'm going to call this animation coin 1. And the reason I'm doing that is because this value, or this coin's value, is value of 1. So this is the coin 1 specific animation. So we're going to key in the texture. Pull this up a bit, zoom this in. 1 second will be fine. Key in the texture again, and then key in the texture again. I'm going to add a little rotation animation to this. And then we're going to go and key in the transform, there we go, and the position. Position in all 3 places. Actually, we'll do this position here, and then in the center, I'm going to hold down Control so I can drag this up a bit easier. To negative, we'll do negative 6-ish, or negative 5-ish. And we'll key in this. I'm going to put these on cubic, put it on loop because I always want this looping. Yeah, that works for me. I'm going to hit save, go back to our collectible entity script, and we're going to want it to play coin 1. Now, in the ready function is where I'm actually going to be firing this or calling this function. The reason I'm doing that is because our collectibles are going to be set to their specific types, depending on a resource, right? And that's going to be setting on ready. So we want to make sure that it knows exactly what animation to play. And because this is a permanently looping animation, it doesn't need to reset the animation to when it won't need to do anything else or anything different. And of course, to add to this, all we're going to need to do is match to a different type, right? And then play a different animation based off of that type. I'm going to first make sure that this works by going to our sprite 2D and removing the sprite. That way, our collectible entity just doesn't have a sprite, so we'll know immediately if it doesn't work. Then in our ready function, I'm going to call handle animation, hit Control S, and this should be our collectibles handled and managed and expandable. Let's go and make sure it's functioning. I didn't name this collectible type. For those of you that caught that, well done. There we go. Now our animation is playing, the coins are bouncing, our counters are incrementing, and we're done. We're set. That is collectibles handled and managed. In a future video, I will show you how to actually implement some UI and allow that to interact with each other, and a lot of different types of items, whether it's potions or, as I said before, levers, and pretty much anything that's collectible or interactable. But for now, thank you for watching. I hope you enjoyed, and I will see you in the next video.